Mutualism is a type of interspecies relationship in which both species benefit from their interactions. There are a number of benefits a species might gain from such a relationship. Protection, pollination, dispersal, cleaning in the form of parasite and dead tissue removal, shelter, and nutrition are all possible examples. Mutualistic relationships can be either obligate or facultative. Obligate mutualism is where the survival of one or both organisms is dependent upon the relationship. Facultative mutualism is where one or both organisms benefit from but are not dependent upon the relationship for survival. A mutualistic relationship could be both obligate and facultative if species A is dependent on species B and species B benefits from but is not dependent on species A. Now let's look at some mutualistic relationships in action.
Honeybees and flowering plants have a mutually obligate relationship because both organisms benefit from interacting with each other and their populations could not survive without the other organism. Honeybees need the nectar and pollen from flowers to convert into food and to use as building materials to construct hives, while flowering plants need the bees to carry their pollen to other flowers in order to reproduce. In isolation, neither species could survive because each species plays an essential role in each other's life and reproductive cycles. Some ant and aphid species share a mutually facultative relationship. Ants will farm aphids for a honeydew waste product the aphids create, while aphids benefit from the ants because they receive their protection from predation. The ants, however, do not rely on the aphid honeydew as a food source, and while aphids benefit from protection, they do not require it to maintain and grow their population. Therefore, in isolation from each other, the population size and carrying capacity of these two individual species would likely match the available natural habitat.
There are 4 possible outcomes to the mutualism model. Scenarios 1 and 2 are facultative, meaning that one species can survive without the other. Scenario 1 is known as the runaway system. In this system, an increase in population of one species leads to the increase in population of other. The carrying capacities of the species would look like this. Anything above carrying capacity for species 1 would lead to a decline in population, and anything below would lead to an increase. Anything to the left of species 2 carrying capacity would lead to an increase in population, anything to the right would lead to a decrease. This area in the middle shows the population of both species will increase, and this will happen until you run out of space. Scenario 2 is known as the stable facultative system. It is stable because an increase or decrease in the population of either species will lead to an intersection of the carrying capacities, allowing both species to maintain a stable population. As you can see, adding the vectors together at any point in the graph points to the middle and gives a stable population. Scenarios 3 and 4 make the assumption that both species participate in obligate mutualism, meaning that one species cannot survive without the other having their population at a certain size. Scenario 3 is known as collapsing system. This occurs when the carrying capacity is below the minimum viable population size. As stated before, since these species are obligate mutualists, they need one another to survive, and that can happen if one or both of them is below carrying capacity. In this model, there are 2 outcomes. Either one species grows while the other declines, or they both decline. There is no happy middle. Scenario 4 is known as the unstable system. This model is similar to the runaway system, but instead of there being a wide range where both species can benefit, there's just this one section. This model is unstable because you will not be able to stay in the middle because of the rise or decline of species will cause the other to rise or decline as well and put you somewhere in the system.